2A. Today we're going to start talking about how to verify identities. The good thing is we're not actually going to verify identities. We're just going to do it in class, and for homework you're just going to keep kind of looking at other methods to simplify stuff. So tomorrow when we're verifying identities, we know most of the tricks of the trade. All right, so verifying identities. Some people are still writing, so I will hold off for a second. All right, verifying identities. To verify an identity, it means to prove that both sides of the equation are equal. So you're going to show both sides of that equation are equal. But there's a few rules that you need to follow. When working with trig identities, choose which side of the equation to start with. So you're just going to pick one side, and you're going to work on that side until you get down to like a stopping point or they're equal. It is usually easier to start on the more complicated of the two sides, and I'll show you what I mean in a second. It says simplify this side until it reduces to the other side. Use the trig identities in algebra to make one side look like the other. That's what we're saying. Never work on both sides of the equation at the same time, i.e., you're no longer allowed to subtract a value from both sides. You're not allowed to multiply both sides by 2. You're not allowed to divide both sides by sine x. You're going to build like a wall between the two things, and you only can work on one side at a time. You can never move something from this side to that side to make it easier on yourself. All right? So here's going to be our first example of verifying a trig identity. So we're verifying the identity that 1 plus secant x sine x tan x equals secant squared x. Here's something that's important. Anytime I tell you to verify something, it is possible. I'm not going to give you one that isn't possible, that I'm just like at the end of the day, I'm like, I got you guys. You couldn't actually do that one. All right, so that will never happen. So no matter how hard it is, there is a way to verify that it is true. I will give you nothing but true statements. All right, when you're verifying an identity, this is what I do. I put a line that separates the two sides, letting me know that I couldn't subtract 1 from both sides. I'm not allowed to subtract 1 from both sides. I'm not allowed to divide by secant. I can't do anything. I need to pick a side, work on it till it gets a stopping point, and then if I need to, I can go to their side and work on that side, but you can't work them at the same time. Now, like it says up there, usually you pick the more complicated of the two sides. This is just secant squared. This is 1 plus secant times sine times tangent, so this is our more complicated side. We're going to work on this side. All we're going to really do is simplify this side. We're going to simplify this side as best we can and hope it comes out to being that secant squared x. So the first thing I'm going to note, see how this is secant? Well, when I'm simplifying this, the easiest way we can to simplify stuff is to hold on to maybe that secant here. Because that secant's okay. Maybe we can get rid of some of this stuff. All right, because we have this long fraction, we need to get rid of that long fraction. So maybe the easier way is to do our old trick of turning everything into sine and cosine. So that's always a good attempt at your first idea, is to convert things to sine and cosine first. So if I want to change secant, I can just change that to 1 over cosine x. Sine is already sine. I might leave it as sine x over 1 to help me recognize that it's a chain of fractions. And tangent, well, cotangent is cosine over sine. So that must mean that tangent is sine over cosine. Quick reminder of fractions multiplying. You multiply the tops, and then you multiply the bottoms. So you go all the way across. So I'd have 1 times sine. And so we're going to have 1 plus sine times sine is sine squared. Over cosine times cosine is cosine squared x. Well, that simplifies down to 1 plus sine squared over cosine. Sine over cosine is tangent. So it's going to be 1 plus tangent squared x. Now I have a 1 plus tangent squared. And anytime you have a 1 and something squared, you should look at your Pythagorean identities. Is there a Pythagorean identity that says 1 plus tangent squared equals anything?
Yeah.
What does it equal? It equals secant squared. So this side just equals secant squared. So now what you're going to do is you're going to bring this down. And we have secant squared x equals secant squared x. We're done. That's all we need to do is pick a side, simplify it, and hope it comes out to the other side. Like I said, we're not going to do much of this in the homework. In fact, I don't think we're doing any verifying in the homework tonight. Tonight we need to practice some algebra skills that deal with trig functions. First of all, finding products. Finding products when you're multiplying two things. So we have a binomial times a binomial. But this is a nice binomial. It is 1 plus tangent, 1 minus tangent. We have done this a lot. This is a minus b times a plus b. So it's just going to be a squared minus b squared, so that's just going to be 1 minus tangent x. The quicker you recognize that, the easier life is. Our next one is 2 times sine alpha plus 1 squared. Well, that's just 2 times sine alpha plus 1 times 2 times sine alpha plus 1. Now you can either FOIL this, first outside, inside, last kind of thing, but however you want to do it, we need to get these distributed. What I do a lot of times is I take this and I multiply it by both of these, which would give me a 4 sine squared alpha plus 2 sine alpha. Then I take the second term in the first binomial and multiply it by those two. I just distribute, which would be 2 sine alpha plus 1, which is reduced down to 4 sine squared alpha plus 4 sine alpha plus 1. But that is just multiplying. That is a binomial times a binomial. All right, factoring. We're supposed to factor each of these expressions. So the first one is a squared minus b squared. The easiest way to factor a squared minus b squared is to do a minus b times a plus b. So in this case, we're going to have sine or secant x minus tan x times secant x plus tangent x. B is kind of a dumb example because normally you just look at your Pythagorean identities and you'd actually solve it. But if it said factor that, this is actually a difference of squares. This is a difference of squares because this is really just 1 squared. You can picture that as being 1 squared. So factoring this one would just be 1 minus cotangent x times 1 plus cotangent x. All right, for our next one, we have sine squared plus sine of b minus 2. Well, just remember how you could think about this. This is really sine beta squared plus sine beta minus 2, which you can kind of picture as, or when you're thinking about it, if this helps you at all, think x squared plus x minus 2. That's what I want you to think about. Well, when you factor this, it's going to turn into a binomial times a binomial. So in this case, we would have x and an x, and we would have x plus 2, x minus 1. So bringing our sine of beta back in, this would actually equal sine of beta plus 2, sine of beta minus 1. All right, so when we're factoring, we're just treating them like x squareds and x's. Everything still applies. And in fact, in our last example, that's exactly what we're going to do. We're actually going to go all the way through it with x's instead of sine of x's. So our last example of factoring, some factoring review. This is the only time I'm really going to, in class, go over how to factor something. All right, we are pre-calc students. If you don't know how to factor something, you need to come see me and work on it. For factoring, there's multiple methods. I'm going to use the grouping methods, but somebody uses like the snowflake methods, other methods. I don't know how are the methods out there. We need to factor 8 sine squared minus 10 of x minus 3. We are going to replace sine x with x. We're going to replace sine x with x. So I'm going to rewrite this as 8x squared minus 10x minus 3. You do not have to do this. It just can make it easier to work it with x's rather than having to write sine x over and over and over again. All right. When I factor, I use factor by grouping. With factor by grouping, I need to locate a couple letters. This is my a value. This is my b value. This is my c value. With factor by grouping, you make columns over to the other side. In one of your columns, you are going to do your a. Your b value, you just take your b value, which is negative 10. This is your multiplication column. This is your addition column. You're looking for two numbers that multiply together to give you negative 24, like negative 2 and 12. 2 and negative 12. But we're looking for eventually where they add to give me 10. Well, 2 and 12, the difference is 10. So we are actually going to use 2 and 12 because one of them needs to be negative. So you might try a bunch of stuff to start off with. Well, 2 and negative 12 equals negative 24. And 2 plus negative 12 equals negative 10. So 2 and negative 12 are those two numbers that work in both those columns. With factor by grouping, what you do with these two numbers is you split apart this 10. And that's because 2 minus 12 does equal 10. So we're going to divide this up. We're going to write this as 8x squared. And we're going to go plus 2x minus 12x minus 3. So you break apart your middle term. Now you have a binomial minus a binomial. Because at the end of the day, we need a binomial times a binomial. And right now I have a binomial minus a binomial. But we have two special sections. We have this guy, and we're going to have this binomial here. And we're going to treat them as binomials. We are going to factor out the biggest thing I can out of 8x squared and 2x, which is going to be 2x. So I'm going to rewrite this as 8 divided by 2 is 4x plus 1. Then we're going to do the same thing with negative 12x minus 3. The biggest thing you can pull out of negative 12 and negative 3 is a negative 3. So we're going to pull out a negative 3, which will give me a positive 4x and a positive 1. The reason why I always go with factor by grouping is because there's a checkpoint right here. If those two things are the same, you did everything correct. All of your steps were correct all along the way. Now all you have to do is smoosh these guys together. So I'll have 2x minus 3 times 4x plus 1. Now, since we replace sine x with x, we're just going to take that sine of x and plug it in place of those two x's, which will give me 2 sine x minus 3, 4 sine x plus 1. You are not required to do this method, but I strongly recommend that you at least know one method, because on the test, guess and check probably isn't going to be your best method, because that is a method, guess and check, where you go all the way through, but I could put giant numbers on there where guess and check is just not going to fly. So you have to know at least one method. At least one method, I don't care what it is. You'll get the most points for this one if you make mistakes along the way, like the snowflake or the star method or something. If you make mistakes on there and I don't know what it is, then you're going to lose more points than if you did something like this. All right, questions for me? Like I said, your homework doesn't have any verifying identities. It is just practicing simplifying, and tomorrow we will verify, or Monday I should say, we will verify some identities.